Okay, you've learnt a lot about echo now, but sometimes it's very difficult, especially in a pressure situation. You may see an echo image that is really hard to interpret and it's just sometimes overwhelming. So we developed a system called the DEFG system, and this is a system that you can apply to looking at echo images to help you find all the information you need in a shorter amount of time. We think it's great. So by using a structured system for looking at echo images or clips, this will help you find the abnormalities, more of them and in a faster amount of time. So for instance, if you were to look at this echo image, there's lots going on, and when you first look at it, it's very hard to digest. But if you break it down into digestible chunks, it's more easy to be able to decide and ascertain what the abnormalities are. Okay, so let's start. What does D stand for? Well, D stands for dimensions and structure. Remember we said the right side shouldn't be more than 2/3 the diameter of the left side, and that's on views such as a subcostal 4-chamber and the apical 4-chamber views. So causes of dilated right side might make you think of problems such as massive pulmonary embolus. So the right side should not be more than 2/3 diameter of the left. On the parasternal views, certainly remember we said the left atrium and aortic root should be less than 4 centimeters, and on most of the views, especially on the parasternal long axis, the left ventricular internal diameter and its maximum, i.e. at the end of diastole, should be less than 6 centimeters. We also said that looking at the left ventricle wall, this should be about 1 centimeter thickness in a relaxed state. So this will be in diastole. So obviously the range is between 9 and 12, but 1 centimeter is quite good. Okay, so let's have a look. E stands for effort. So, is the heart pumping well? Now we said globally we can look at narrowing of the left ventricle on views such as the parasternal long axis and also the parasternal short axis and other views, but the narrowing of the cavity of the left ventricle diameter should be reduced by about 30% during systole. We also said that we can look at the thickening of the left ventricular walls, and this is a very, very sensitive way of looking for problems. So look for thickening of the left ventricle walls by 30 to 40% during systole. Does it happen? If not, there may be a problem with effort. We also said as well that looking at things such as the anterior leaflet of the mitral valve, almost touching the wall during diastole may give you an idea that there's a good amount of blood being pumped through the heart and at good velocities. So remember, E is for effort. The next one is F for fluid, around and adjacent to the heart. So, is there any fluid around the heart in the pericardial space? Remember, this can be small or it can be large. Don't get caught out with pericardial fat pads. Remember, they look like starry night. Okay, so little speckles in. And is there fluid adjacent to the heart? For instance, pleural fluid. So F is for fluid. G is for gradients. Now this is where blood flows across valves, where the pressure gradients change, and also it can flow between septal walls. So look for these. What valves can you see? Do they look normal? Remember, the mitral valve is naturally thicker than the aortic valve, which should be barely seen. Are they moving normally? And if there's a view with colour flow Doppler, is abnormal jets. And that may apply also to septal walls. So there may be a hole in the septal wall where there's an abnormal jet shown on colour flow Doppler. So G is for gradients. Okay, so just to summarise, we've got D for dimensions and structure, E for effort, F for fluid, and G for gradients, i.e. valves and abnormal flow. So remember those, and whenever you see an echo image, use that system. Start off with D, work your way through to G. Okay, have fun.